And again, this relationship has been going on for about how long?
About probably 3 years,
Yeah,
I guess.
2-3 years.
From the time it started development. First release was just over a year ago in May. Was the first Dell release of the product, and then we had a second speed bump that we kind of came out with in the December time frame, and we added some significant features there where we added the ability to name an object instead of having to use just that unique unit identifier.
Okay.
So that you can
So
actually.
it's got a worldwide name now?
Yeah, well, it's not
You can do that.
Yeah,
You can do that?
Yeah.
Yeah. Okay.
So it made it more applicable to other areas. We've also come out with a file protocol gateway so that you can have a CIFS and an NFS access to it through a gateway, because some people aren't completely ready to rewrite their software, but they want the advantages of that long-term archive. So we developed a gateway that will again allow people to do a normal mount. They lose some features when they do that, in that if you write native to the application, you can write all your metadata on a per write basis. So I can make 5 copies of your email and 2 copies of mine, or I can do anything that I want to for life points or when it's going to be deleted. If you do it through a gateway, you have to set your policies on each mount. So a D drive might live for 7 years, and an F drive would wind up, you can make it do 19 years or whatever you want. You just set your static policies compared to them being dynamic. So that's about the biggest difference.
If I'm an application developer today that's got some sort of long-term where I need immutability, let's just leave it at that.
Right.
But I'm writing a new application. Pretty straightforward.
It is. You can write standard HTTP calls, but to make it even easier than that, on support.dell.com, there's a complete open source SDK that has bindings in multiple languages: Java, C#, C++, Python. You can download that. Literally, you can be writing content into the DX in a matter of minutes.
Okay, but if I was a guy who already developed the application and maybe I was integrated with a Centera Atmos kind of or Atmos approach, what's the process for sort of for making a migration or making this an alternative?
Right. It's fairly simple, and that was where named objects, as we call them, came in. Originally, when the first version of the DX only had the ability to be assigned a key by the DX, you then had to store that in your application. Some applications didn't want that.
Right.
They said, we create our own name. We even build semantics into the name. It might have an account number, that type of thing. So now with both naming schemes available, it really is simply a matter of changing your rights to the file system to posts to HTTP, and either storing the key you get back or using the name you've already been using all along. It really is that straightforward.
And so there's a lot of hybrid use cases. So they'll write specific application servers to write all this data, but they may have a simple web browser application for people to pull data. If you want to pull back a map or a picture, you just type in the HTTP, and you can hide that behind a little plug-in to any type of an app. So the access method, you can use the SDK and you can write all the things that you need to with the software, but then you can retrieve it. Very often when I'm doing a demo, I'll write a script or something and show a bunch of things, and then we'll just type in an IP address and URL, and boom, here comes back the picture of the Parthenon, whatever you want to see, so that you can show.
Actually starts bringing some interesting use cases that I don't think you would have ever thought of in the storage world. You can actually post HTML and JavaScript into a DX cluster and use it as a web server and bring those pages back. So there are some things like that. You can plug a search appliance into it like you would normally.
I was going to ask.
Full text index and metadata index the entire storage system, and then have full text search capability of your entire system.
With some of the unstructured data, particularly around images and stuff like that, obviously with images, hopefully there's been some tagging, and I can do some searching on that. Are there other capabilities in terms of search that are sort of interesting to you to enable people to search through things that don't have a lot of metadata, or maybe you use it to create metadata?
All of the above.
Can you talk about it? Can you talk about it?
Oh, yeah.
Well, let me jump on that first, and then Gene, feel free to chime in. So in addition to full text search, that type of thing, we also have a product called the Content Router. And you can, when you write data, you can do custom tagging, as you said.
Right.
So in addition to standard metadata, such as timestamps and those types of things, content length, you can add any custom metadata you want. There's in this product called the Content Router, you can write rules against that metadata to generate lists of content that are in the system that meet criteria, such as tagged as, send to the Southwest region, whatever it is. That then is available to get that stream of data and do whatever you want with it. By default, we have a system that will replicate it to other DX clusters anywhere in the world. So that's why it's content replication, the content router. It will route anywhere in the world subsets of the data, but it's an open API, so you can do whatever you can dream up with that API as well.
Right.
In our December release, in our second release, Dell actually created a set of standardized metadata tags, and we're encouraging, not completely requiring, but strongly encouraging our ISV partners to write a set of standardized metadata tags down with the object whenever they're creating the objects. And this medical, for instance, was a big ask for this, because they may have 5 or 6 applications in a hospital that all need to be archived. Well,
right.
the only search was each individual application, so the payroll app versus the pharmacy versus the cardiology, each one of them had their individual, and they couldn't search across all things. But if they get each of those apps to fill the metadata field, then they can search and find all of the instances of Mike Melson, and we can mark him as dead or whatever we need to there in the metadata. We can modify your metadata, you know. But we can say Mike found a cure for cancer, and we can update that across all of the records.
Thank you for going positive.
Yeah,
appreciate that.
There you go.
Well, and actually, Michael Dell talked a little bit about that in the keynote today, is around how the medical community has been, in some ways, very non-science based, and so, and some of that's driven by privacy, right? Because I'd like to know how it worked out for you when you took that medication, but for privacy reasons, I don't get to.
Right.
So are you seeing interesting applications?
Some of the most
Very much so.
most cutting edge things that I've seen have just come out of conversations with people in the medical, because they're usually pretty willing to, they write their own software anyway, so they're not scared about making a port or thing. And we were in a conversation with a big medical company out on the West Coast, and they were saying, well, we can just do HTTP range reads and make it work. And I went, what? Explain that. Well, you can read in HTTP a chunk of a file without having to read the whole file from end to end. So they want to write like 10 copies of the file and retrieve 10 chunks of that file and put them back together, so they're retrieving it 10 times faster than they would from a file system for picking it up from the beginning to the end. And we're just going, well, it's just a standard part of HTTP. It just exists out there, but for someone to create that creative application to do that, and they want to see their medical images faster than their competitors, so they're out figuring out ways to do that. The other thing they can do, since we have the ability to write multiple copies, the default is like a minimum of 2 and a maximum of 16, but you can change those things. So they want to write like 15 copies of the application or the object when it's first created, so that a lot of doctors for the first couple of weeks can get to it, and then 2 weeks later it has a tag that drops it down to 2 copies for the longer term retention. And so that type of metadata manipulation and tagging can be created at the time that the object is written, instead of having to be post-processed. So you can, they'd also possibly have a tag that said delete this file at the end of 7 years, and so your application doesn't have to go crawl file systems to create deletes. They're just life points that exist. So it's a different kind of tool.
Now, Perot Systems has got a lot of expertise in the area of medical, right?
Correct.
And so, how are you three? I mean, you're not part of Perot. Perot's part of Dell. But how does Caringo, Dell proper, and Perot System work together?
Very well together. We have a large, still I think in prototype stage, but it's a large application for Stanford Medical that Perot was involved in supporting out in California, and we actually set up DX clusters with TerraMedica, one of our use partners. And so TerraMedica performs the whole Paxis layer to connect to all the modalities, and then as they pool the product in EqualLogic for their almost spooling type of storage, well, it has to stay there until it reaches a level of maturity that it's reached, the doctors updated it, the pharmacy, the different thing, and then it automatically moves through and is stored into the DX with the long-time archive function. And then they replicate between their 2 hospitals so that they've got complete copies of everything that's one and the other. And that was all a Perot integration. Perot did all of there's some significant networking can get involved in this, and so that's where Perot and those people do an awesome job, because they'll go in and consult and analyze and figure out a person's network so that they overcome the fears of going through it. So they've been great partners, and it's fun because they're smart people and they learn fast, and so as the more you work with them, they instantly start coming up with new ideas, and well, I can use this over here, I can use it over there, because they see that use case evolving. So
we were talking to some of the Oak Arena team, and when you start thinking about replicating data over distance, and some of this data is particularly medical and entertainment, so some of those files get mighty big and could suck up a lot of bandwidth. So What's the opportunity? But you've got to, if you've got to preserve content in its immutable state,
Correct.
right? How do you guys work together? What's the opportunity for you guys to work together long term? What can you do? What can't you do?
I think it's a tremendous opportunity when you look at the intelligence of the Ocarina solution. It really goes about how they do compression and dedupe very, very differently and very, very smartly. So it really is just a beautiful marriage of two very compatible technologies. I think you heard earlier that Ocarina and DX are going to be integrated very soon here, the first to integrate the Ocarina technology. I think it makes a lot of sense to bring that out first because they add so much value to the immutable story because of the way they do it.
I appreciate you guys coming on theCUBE.